This video will cover section 10C notes, which is talking about the Pythagorean theorem. Now, the Pythagorean theorem, the reason it's called that is because it was discovered by a Greek mathematician, Pythagoras, who gave us the well-known formula that is used with right triangles. Now, most likely you have learned and used the Pythagorean theorem before, but now we're going to look at how the Pythagorean theorem works with the radicals and how we've been simplifying radicals. So, just kind of a review though, for these figures, the right triangles, the longest side is called the hypotenuse. Okay, so I'm going to draw a picture of a right triangle here in this white space. So I want you to do that. And it's a right triangle because this little square symbol right there, remember, means that that's a 90-degree angle. So the hypotenuse is the longest side, and it's across from the 90-degree angle. Okay, so that's the hypotenuse there. And with the Pythagorean theorem, we typically call that hypotenuse the C value. Okay? Now, the other values are called the legs. So if C is the hypotenuse, then the other two are called the legs. So the legs form that 90-degree angle. So one leg we'll call A, and the other leg we'll call B. Okay? So, like I said, you've done this before, or you should have. So we have A, B, and C, and with C being the hypotenuse, so the Pythagorean theorem says that if we have A, B, and C, then A squared plus B squared equals C squared. All right, so for the first example, we're going to do a pretty easy one, probably very similar to one you've done before. So our two legs, we have 5 and 12. And then our missing length, the end value, is our hypotenuse, is the C. So if we do A squared plus B squared equals C squared here, A is the 5. So we would have 5 squared. Then the B is 12, so that would be plus 12 squared. And then the C is a variable, and we're going to call that n squared. So let's go ahead and simplify. We know 5 squared is 25. 12 squared is 144. And then 144 plus 25 is 169. Now, hopefully, you remember this is one of the ones that I told you to memorize. 169 is a perfect square. Now, I'm trying to figure out what n is. And n is being squared. So remember we talked about what undoes a squared. Well, if I were to take the square root of whatever I do to one side, I have to do to both sides. If I take the square root of n squared, what happens is that square root and the squared cancel out, leaving me just with an n. And then the square root of 169 is 13. So that means that the missing side length has a length of 13. Okay, so hopefully you've done something like that before, but now we're going to look at when we don't have a perfect square, we have different radicals, things like that. All right, so let's look at example B. First of all, I want to label my A, B, and C. Now, notice that this triangle is different than the A in that the right angle is on the opposite side. So remember that the C, the hypotenuse, is just across from the 90-degree angle. Then A and B, it really doesn't matter which one is A and B, so just make sure you know that those are the legs. All right, so if I do A squared plus B squared, then this would be X squared, that would be A squared, plus B squared, 6 squared, equals our C is 2 root 13. Now, whenever you're substituting, we like to use parentheses. Notice I have not used parentheses with my X and my 6, really because they're a single positive term. But the 2 root 13, if I wrote 2 root 13 squared, what that means is I'm not just squaring the root 13, I'm also squaring the 2. That's really, really important. If you have more than just a positive single term like X and 6, you have to put parentheses around it when you square it. So 2 root 13 has to have parentheses. Okay, so now X squared plus 6 squared, we cannot simplify that right now. Well, actually, sorry, 6 squared we can. So that's 36. All right, now when we get to 2 root 13 times 2 root 13, you can do this a couple of ways. You could write it out. So 2 root 13 squared is 2 root 13 times 2 root 13. So when I multiply that, you multiply the like things. So notice this is not double distribute because there are no pluses or minuses. We're just going to multiply the coefficients. So that would be 2 times 2 is 4. And then we're going to multiply what's underneath the radical together. Okay, and notice that we're multiplying the square root of 13 times the square root of 13. And remember, if you're multiplying the same square root, then those square roots can really just cancel, leaving you with 13. Or you could have written the square root of 169, which then would be 13. Another way of thinking about it is back up at the top, when I'm multiplying two things together, like 2 times root 13, and I'm squaring that, you can think of that square as like distributing to both things. So you can think of that as 2 squared times the square root of 13 squared. 2 squared would then become 4, and the square root of 13 squared would then be 13. Okay, so that's kind of a shortcut way. I prefer that way, but if you need to write it out, you can write it out. All right, so we have the x squared plus 36, and then we have 4 times 13. So 4 times 13 is going to be 52. So now we have an equation. We have x squared plus 36 equals 52. I'm trying to get x by itself, so the next thing that I would do would be to subtract 36. So we have x squared equals 52 minus 36, 16. And then x squared equals 16. To get x by itself, we take the square root of both sides. Square root of x squared just becomes x, and x equals the square root of 16, which is 4. So that's my missing side. Okay? We're going to do one more example like that, then we're going to try some different examples. All right, example C. Again, we want to label our A, B, and C. A and B here are actually the same thing. It's both n, and then our C is 7 root 2. So if you do the Pythagorean theorem, a squared plus b squared for this example would be n squared plus n squared is equal to 7 root 2, remember we need parentheses, squared. N squared plus n squared, that's like terms. So I have one n squared plus another n squared, so that gives me 2n squared. The exponents do not change when you're adding. And the 7 root 2 squared, remember, think about this as the squared is distributing to both the 7 and the square root of 2. So 7 squared, you get 49. And then the square root of 2 squared just cancels out the square root, so you just get 2. All right, now, if you notice, before I keep going, actually, I don't have to multiply 49 times 2. Because you have this 2 over here that we're going to be eventually dividing by anyway. So I'm going to save myself a step and go ahead, and those 2's are just going to cancel out. So that's nice. So now we just have n squared equals 49. You can already see the answer, so take the square root of both sides, and n is equal to the square root of 49, which is 7. Okay, so that's how you do Pythagorean theorem with radicals. So now for example 2, we're going to take this a little step further, and instead of giving you a triangle, a right triangle, I'm going to give you a trapezoid with a right triangle inside of it. Okay, so this is a trapezoid, this figure that you see here. And they give us some lengths, and they want us to find the value of k, which is here. And so it gives you a hint. It says to find the right triangle first. So you can easily see the right triangle is, I should make it blue, hold on. If I trace this triangle, there you go, you have that right triangle. Okay, now you see that the one leg of the triangle is 10, so we need to figure out what the other leg of the triangle is, which is this one right here. So this whole length is 20. I see that this length is 15, so this rectangle here, this would also be 15. And so if that length is 15, the whole length is 20, that means that this little length right here would have to be 20 minus 15, which would be 5. Okay? So we see our right triangle has a leg of 5, a leg of 10, and then the hypotenuse is k. So then when we write our equation for Pythagorean theorem, our two legs, 5 and 10, would be 5 squared plus 10 squared equals the hypotenuse, which is k squared. So now let's simplify. 5 squared is 25. 10 squared is 100. And then 100 plus 25 is 125. Okay, now that we have both sides simplified, we want to get rid of the squared, so we take the square root of both sides. So square root of k squared gives us just k. However, the square root of 125 is not a perfect square. So when you have not a perfect square, you have to simplify that. So 125, you look for the perfect square that multiplies to get 125. That would be 25. So 25 times 5 is 125. And then simplify. The square root of 25 is 5. The square root still has a 5 underneath, and that equals k. So that is my simplified radical for k. All right, for example 3, we don't have a picture, so we need to draw a picture. It says the diagonal of a square. What that's talking about is if I draw a square, and we'll say that the side lengths here are the same. If I draw the diagonal, so that's the length from one corner to the opposite corner, that's called the diagonal of a square. So that length is 5 root 6. Now notice what happens when I draw the diagonal of a square. You get this right triangle. And since that square, all sides are equal, you have the two sides of that triangle being x by x, and then the hypotenuse is 5 root 6. So if we want to find the length of that square, we would say that's x squared, that's a squared, plus b is also x, so plus another x squared, equals 5 root 6 in parentheses squared. So x squared plus x squared, we've done one like this before, are like terms, so I add their coefficients of 1 to get 2x squared. Then 5 root 6, remember that's 5 times root 6, so the squared goes to both the 5 and the square root of 6. So 5 squared is 25. Square root of 6 squared cancels, giving me just 6. All right, again, I can still kind of do this shortcut. I don't necessarily have to multiply 25 times 6. You can if you want to, but I know that I'm going to be dividing by 2. And so I like to do as little work as possible. So I'm going to go ahead and divide by 2, and if you see, 6 divides by 2 to give me 3. So now I really just have to multiply 25 times 3, which to me seems easier. So 25 times 3 is 75. I've already divided by that 2, so we don't have to worry about that. So now we have x squared equals 75. I want x by itself, so we're going to take the square root of 75. Again, 75 is not a perfect square. So what is the perfect square that goes into 75? 25. So 25 times 3. We're actually just kind of undoing that. And then the square root of 25 becomes 5, square root of 3. So that is the side length of my square. All right, for example 4, this is the last example I'm going to do in this video. So example 4, we have a similar problem. We have a rectangle instead of a square this time. And its measures are 5 by 2 root 5. So the length is 5, the width is 2 root 5. Find the length of its diagonal. So again, the diagonal would just be connecting opposite corners. So that's what we want to find. So again, you see we have this right triangle inside that rectangle. Okay? So our hypotenuse is the longest side. So the x is the hypotenuse. That's like the c value. And the 5 and the 2 root 5 are the a and the b. So now apply the Pythagorean theorem. So 5 squared plus 2 root 5. That's both 2 and root 5, so we want to put that in parentheses squared. And that's going to equal our hypotenuse, which in this case is going to be x squared. Simplify. 5 squared is 25. 2 root 5, again, that squared distributes to both the 2 and the root 5. So 2 squared is 4. Square root of 5 squared cancels, so we're just left with 5. We can still kind of put that in parentheses if you want, equals x squared. So 5 times 4 is 20, and so then when we add 25 plus 20, we get 45 equals x squared. And now to find x, we simply take the square root of both sides. And so we look for the perfect square that's inside 45, which is 9 times 5. And so then the square root of 9 is 3, so our x is equal to 3 root 5. All right, so that's the last example for the video. So in class, we will have some extended notes. We're going to do the last 3 examples.